Okay, so now we're here in GeoGebra, and we're going to investigate dilations. All right, this is the fourth transformation, and let's investigate. So we got this dilation thing. You see this bar moving on this left-hand side. Notice how I can make ABC, this tan triangle. I can make it really big, or I can make it really small. All right, and notice that when I'm at 1. Wow, interesting. It's the same. We're going to investigate that more later. But anyways, it's telling us let's do a dilation with a scale factor of 3. And let's see what happens. Boom, perfect, 3. Alright, so now I'm just going to go ahead and plot those points and make it look real pretty. So 15, 6. So let's see, can I do it like this? There we go, just help me with my graph. 15, 6. Is right there, and that's going to be B prime. I don't even write that down. 15, 6. C is at 33, 3. And then A is at 36, 40. Ooh, wait, hold on. Yeah, I messed up a little bit. I didn't make this. Wait, hold on. Time out. I meant minor brain fart. 12, 15. I was dilating what was already dilated. 12, 15. Me mess up. That doesn't sound characteristic of something I would do. All right. A prime is at 12. Oops. We'll just write it like that. Alright, nonetheless, this is the enlarged triangle. Notice how it got bigger when the number was 3. Alright, furthermore, something cool, you don't necessarily have to do this, but notice how all these points converge. I can make a line, if I go from A prime to A, and keep going, it goes to the center. Same with B and C. Wow, look how it's like stretching from the center, stretching from the origin. Alright, so remember this point right here is 0, 0, or we call it the origin. Alright, so that's when I made this scale factor of 3. What happens if I do a scale factor of 1/2? Alright, so notice how the closer I get to 1, the more it gets back to its original side. And once I go past 1, it's actually getting smaller, 1/2. Alright, and look at these points I got right there. Alright, C is now at 5.55 or 5.505. So we're kind of guesstimate C prime 5.5 0.5. B is at 2.51. And A is at 2.5. Alright, and then just to emphasize things, look, that's pretty cool how it all converges back to the center again. Alright, and some other things I would like to mention is, like, let's look at C, because that seems to be the easy one to look at. Let's go up to this original one. Here, I'm going to just get rid of GeoGebra now. Go away, GeoGebra, we don't need you anymore. Alright, looking at C, C prime was 33, 3. C was 11, 1. The scale factor, the dilation was 3. So notice how we just took each point and multiplied by 3. Weird, alright, and that's true for the other points. Similarly, I mean, my handwriting's a little sloppy down here, but you're just going to have to deal with it. 11, 1 was C, 5.5, 0.05. We just multiplied it by half, alright? So whatever the scale factor is, that's what we're actually multiplying each point by, all right? And that's kind of going to be a big punchline moving forward, all right? Compared to the transformations we learned in Unit 4, translation, reflection, and rotation, how is this new transformation different? Side lengths change, all right? It doesn't preserve side lengths anymore. These are non-congruent slash rigid. Non-congruent slash non-rigid. Yeah. And you can actually, sometimes people call this a soft transformation, not a rigid. You can call it a soft. All right. Angles, what's going on with angles? A little foreshadowing, the angles actually stay the same. Pretty cool if you think about it, but we'll go more in detail in that in the future. And then we'll just knock this part right out now. Yeah, we can still do this page. All right. So things to know about dilations, non-rigid transformations. Dilations reduce. So if you say reduce, reduction, whatever, reduce or enlarge a figure. So they're either going to make it bigger or smaller. So in this example above, this first one right here, that was an enlargement. This was a reduction. All right. Dilations preserve angles, but not sides. And if you think about it, like if you were to enlarge or shrink yourself, like you would still have the same proportions. Like your head wouldn't get really big, or your eyes wouldn't get really far apart, or your knees wouldn't stay really big, but your ankles get really small. It preserves angles, all right? Your proportion's still the same, all right? The scale factor, and now my dog's barking at 5:31 in the morning, I'm gonna have to go get him soon, is the ratio of the side length of an image to the corresponding side length of the original figure. So like in some of the examples from above, the scale factor was 3 or 1/2, so on and so forth. And this one got a little sloppy in my, let me rewrite this, but we solved this above with translations. This is now with dilations where it's kx, ky. All right, notice how we're multiplying. All right, that's a big punchline. We are multiplying. And k is always the same in both one. All right, it's not x plus a or y plus b. It's kx, ky. That's the coordinate notation for translations. That's what we're going to use to describe them most of the time. And if k is between 0 and 1, it's a reduction. And if k is bigger than 1, it's an enlargement. And we saw that above with 3 and 1/2. All right, 3 made it bigger, 1/2 made it smaller. And these right here, these are just examples in a coordinate plane, some stuff we're going to be doing in the future. Yeah, pretty cool. All right, this video is ended, so I can go get my dog.